6.陈子帅 Question 6.陈子帅。黄景瑜 Question 6. Page 207. Question 6. So marginal cost equals average cost when average cost is constant. And he said furthermore, if the average cost is U-shaped, MC equals AC at the point of minimum average cost. I have just told you, right? If MP is equal to AP, that is at the maximum of AP, and reversely, because MC is negatively related to MP, AC is negatively related to AP, so AC and MC intersects at the minimum of AC. And he says, suppose the total cost is TC of Q equals Q squared plus 4. The associated marginal cost is MC, okay, so TC. So TC is equal to Q squared plus 4, okay? Right? So Wang Jingyu, what's MC? Differentiate TC with respect to Q, right? So what is MC? 2Q, okay? And then he said, sketch the MC and AC curves on the same set of axes. And what output does the average cost reach its minimum? So actually, the answer is in the question. So it said when MC is equal to AC, you get the minimum of AC, right? So what is MC? MC is equal to 2Q, right? And what is AC? This is TC, right? This is TC. AC is equal to Q squared plus 4 divided by Q, right? So here you have MC, and here you have AC. So 2Q squared is equal to Q squared plus 4. So Q squared is equal to 4. So Q is equal to 2. Okay? So it's easy. As for the diagram, please draw on your own. It is a little bit complicated. So you just plug in all the number that you can get. So here you have Q, here you have cost, right? So you plug in Q, and then you can get, sorry. You plug in Q, and then you can get the cost, okay? And so you will be able to find out what would be the average cost curve and also marginal cost curve, okay? Marginal cost should be easy, right? Because it's equal to 2Q, okay? So MC is, sorry. Okay? And supposedly, when Q is equal to 2, that's the minimum. So Q is equal to 2, well, here, right? Equal to 2, then here is 4 plus 4, so it's equal to 4. So it'll be something like this. Okay, something like this. Okay? Okay, question 7. So we will have such question in the final, okay? You've got to be very careful. We will have such question in the final. 陈子帅, do you get it? Okay. Okay, question 7 is that give an algebraic or geometric proof that given fixed factor prices, decreasing returns to scale in production leads to increasing long-run average cost. Okay, so how to deal with it? If we put it the other way, right? So It means if you have increasing returns to scale, then you have decreasing long run average cost curve. So let me put that down for you. Okay, you have increasing returns, sorry, then you have okay, if you have increasing returns to scale, you get decreasing long-run average cost. So first of all, in terms of economics, you always want to remember the definition. So return to scale. Okay, what's the definition? The definition is F LK is equal to Q. Okay, then you want to compare TL, TK, TQ. Okay, you want to compare with this. Whether it's greater, equal, or less. And here what you have, we have increasing returns to scale. So it is this one, okay? Okay, then we want to compare the cost. So the cost is TC, right? Okay? But if you double, then it will be 2TC. Okay, if you triple, it will be 3TC, and now it's T. Okay, so let the cost be C. Okay, so let the cost be C. Okay, and you know how to work that out. So we are going to compare T times C and F T L T K with C over F L K. Okay? Any question? So here, okay, and here. And supposedly you double it, right? I mean, you put it T times, okay? You put it T times. You get T times more L, T times more K, and want to compare with this one. And actually, what you're going to compare is that T times, right? Why? Because in this case, we are trying to figure out, okay, we are getting T times more labor, T times more capital, okay? And this is the production function. You put a T times there, okay? But what you get, you cancel it out, right? Okay? And we want to compare these two. So this is the original one. And here is that you have more T times more L and K. So what you get? The question tells us it is increasing returns to scale, right? It is increasing returns to scale. And so here you have TC, okay? Actually, it is T times Q plus, let us say, delta Q, okay? And here you have C over Q, right? So at this point, we are trying to figure out the average cost curve, the average cost. So the average cost is total cost divided by quantity, production, right? Total cost divided by production, total cost divided by production. And you know that. You put in T times L, T times K, so the cost will be T times, right? Okay? But because it's increasing returns to scale, so actually what you get is more than T times Q. Okay? So the denominator is bigger. Okay, the denominator is bigger. So it is less than, right? Okay, so because of that, if you have increasing retentive scale, the average cost will be decreasing. On the other hand, if you have decreasing returns, decreasing returns to scale, then you will have increasing long run average cost curve. Okay? So it's very simple. So in terms of dealing with economics, you always need to know the definition. So what's the definition of returns to scale? It is here. And increasing returns to scale is greater than TQ. Okay? And from this algebraic, you can see that it's like that. So you have increasing return to scale because the production level you get is more than T times. And so because of that, the cost is actually going down. Okay? This is the original cost, right? Original average cost. And this is the new one, with you put T times L, T times K. And so after you put T times L, T times K, what you get? You get actually the cost going down, right?